Today we'll be covering a couple of different topics. The first of them is how to calculate the length of an arc around the circle. We did talk about some different arcs and I showed you what the formula was, but now we're going to talk about how to use it. Remember, a minor arc is an arc that is less than half the circle, a major arc is more than half the circle, and a semicircle is exactly half. So in this case, they want us to find the length of the arc EF, which is a minor arc. The central angle is 120 degrees, and they want us to tell how long is it, how far is it from E to F if you were walking around the outside of the circle. So what we know is that the radius of the circle is 6 meters. And remember, my equation is the number of degrees over 360 degrees times 2 times pi times the radius. So the number of degrees of this arc is 120. So 120 over 360 times 2 pi radius, which is 6. I can simplify this fraction, and you can do this in the calculator if you need to. 120 over 360 is 1/3. And then 2 times 6 is 12, so 1/3 times 12 pi. And then 1/3 of 12 is 4, so this would be 4 pi. And then you can put 4 pi in the calculator. It comes out to about 13 if we were going to round to the nearest whole number. So about 13 meters from E to F if you walked around the outside. Here I'm told the diameter is 24 centimeters, and they want us to find the length of from C to D. So first, my angle is 60 degrees over 360 degrees times 2 times pi times the radius. The radius, remember, is half of the diameter. So half of 24 is going to be 12. 60 over 360, again, the calculator can simplify this fraction for you. It's 1/6 times, and then 2 times 12 is 24 pi. 1/6 of 24 is 4. So again, we have 4 pi, and that's going to round to 13. In this case, it's centimeters. And that's my arc length. Okay, what if we don't have a picture to go on? A circle has an arc with a measure of 80 degrees, whose arc length is 276.46 pi inches. What is the diameter of the circle? Okay, so let's fill out my formula. I know the arc length, which they just told me is 276.46 pi, equals the angle, which is 80, over 360, times 2 pi, and then times the radius. And this is what I'm looking for because I need the radius to find the diameter. So I can start by dividing both sides by pi because both sides have a pi on them, so this can just cross out. And I'm going to simplify this to 4 over 9. So 276.46 equals 4/9 times the radius. And then I can multiply both sides by 9/4 to eliminate that 4/9. So times 9/4 times 9/4 over here. And then the calculator can tell me that 9/4 times 276.46 is 622.035, so that's my radius. And then I double that to get my diameter, and that's going to be 1244.07. So diameter equals 1244.07, and this is in inches. Okay, next, find the measure of the central angle of an arc if its length is 43.98 pi and the radius is 18. So 43.98 pi, and we're trying to find the measure of the angle that creates this. So that's going to be x over 360 times 2 times pi times the radius, which is 18. So first, I can cross out pi on both sides again. And then 2 times 18 is 36. So 43.98 equals x over 360 times 36. Now 36 over 360, because if I multiplied these, it would go on top. 36 over 360 simplifies to 1/10. So 43.98 equals 1/10 x. And then I'm just going to multiply both sides by 10 to cancel this out. So x equals this times 10, which just moves the decimal one space over, or you can do it in the calculator, of course, which is 439.0 0.8. So this will be in degrees actually, because it's the measure of an arc, and that means it's an arc that's bigger than the whole circle. But anyway, that's how it works out in this case. Okay, so next you remember that you had to convert your calculator to degrees every single time that you were doing a tangent, cosine, or sine calculation. That's because there are two different ways to measure angles. One is degrees and one is radians, and we hadn't talked about radians yet, so here's how you convert between degrees and radians. First, to convert an angle measured in degrees to radians, you multiply the number of degrees by pi over 180, and then simplify the fraction. To convert an angle that's already in radians back over to degrees, you multiply the radians times pi, 180 over pi. That's the basics. Let's look at what this looks like. So converting 225 degrees to radians. To convert to radians, you should multiply by pi over 180, just like we have it written up there. You should only focus on numbers and write pi after the fraction is reduced. So we'll start with 225 over 180, and we'll add the pi on afterwards. I can reduce this to math, enter, 5 over 4. So 5 pi over 4. And you could turn this into a decimal if you wanted to, 1.25, but we really usually prefer to keep it as a fraction, 5 pi over 4 radians. Now let's convert 5 pi over 9 radians to degrees. To convert to degrees, you should multiply by 180 over pi. Since the pi's cancel each other, we should only focus on the numbers again. So it's going to be 5 times 180 divided by 9. And you can do that in whatever order. So if we know that 180 divided by 9 is 20, then we can do that first. And then 20 times 5 is 100. And then 5 pi over 9 and 180 over pi, this pi and this pi cancel out, like we said. So it's just going to be 100 degrees. So the answer is 100 degrees. An angle representing one complete revolution of the unit circle measures 2 pi radians. Formally, how many degrees? Well, we know to go all the way around a circle, it is 360 degrees. We could do the conversion, but that's what it is. 360 degrees in degrees and 2 pi in radians. Change the following radians to degrees. 2 pi equals 360 degrees. Pi, which is half of 2 pi, would be half of 360, so it would be 180. Pi divided by 2, or pi over 2, would be half of that, which would be 90 degrees. Pi over 4 is half of that, which is 45 degrees. 3 pi over 4 is 3 times 45, which is 135 degrees. 11 pi over 6, that's when we're going to go ahead and convert. So 11 pi over 6, and we multiply by 180 over pi. The pi's cancel out. 180 divided by 6 is 30. 30 times 11. 11 times 30 equals 330 degrees. Okay, now let's convert the following degrees to radians. If 360 degrees equals 2 pi, 270 degrees times pi over 180 equals 270 over 180. And we're ignoring the pi and just focusing on the numbers. 270 over 180, if you put it through the calculator, will be 3 over 2. So add the pi back on, 3 pi over 2. 60 degrees. 60 times pi over 180. Let's do 60 over 180. If you run that through the calculator, if you need to, you'll get 1/3. So that's going to be pi over 3. 150 times pi over 180 equals, we do 150 over 180, which is 5 over 6. So 5 pi over 6. 30 degrees, that's going to be half of 60, which is half of 1/3 is a 6, so that would be pi over 6. And then 60 times 4 is 240, so that would be 4 pi over 3.